Across the world, patients given only sugar pills have experienced real pain relief, surges of dopamine, and even tremor control in Parkinson's, without a single active drug. This isn't just in their minds. It's the biology of belief, and understanding it could change how we think about medicine. But just how far can this power go, and where does it stop? A placebo is any treatment that looks and feels real, like a sugar pill or a saline injection, but contains no active medicine. Yet in clinical trials, these inert treatments often lead to genuine improvements in symptoms. Doctors and researchers use placebos as a control condition, comparing them to real drugs to reveal what the medicine itself actually does. To keep results honest, both patients and researchers are kept in the dark about who receives the real treatment and who gets the placebo, a method called double-blind testing. This approach is now the gold standard for medical research worldwide. The surprising part is that people given placebos can experience real pain relief, mood shifts, or even changes in movement, all because the brain responds to the expectation of healing. Far from being imaginary, these effects are measurable in brain scans and blood tests. The power of belief, it turns out, is a force that science can now track and quantify. Expectation alone can set off a chain reaction inside the body. When a person believes they are receiving real treatment, the brain releases endorphins and dopamine, chemicals that play a central role in pain relief and motivation. Endorphins act as natural painkillers, blocking pain signals before they reach conscious awareness. Dopamine is closely tied to reward and movement, and its release can even improve symptoms in conditions like Parkinson's disease. But the effects do not stop at the nervous system. Immune markers in the blood can shift as well, showing that belief can alter how the body defends itself. Scientists now describe the brain as a prediction engine, constantly anticipating what will happen next and preparing the body to respond. In the context of a placebo, these predictions trigger real chemical changes, turning expectation into measurable biology. Fabrizio Benedetti's painkiller experiments delivered a stunning result. Patients given a placebo pill reported pain relief nearly as strong as real opioids. But when scientists introduced naloxone, a drug that blocks the brain's opioid receptors, the relief vanished. This proved that the placebo had triggered the release of natural painkillers, not just a change in attitude. In another trial, Bruce Moseley's team performed sham knee surgeries on patients with osteoarthritis. They made incisions and simulated the operation, but never touched the joint. Months later, these patients walked with the same ease and reported the same pain relief as those who had real surgery. The ritual of treatment alone was enough to change lives. Alejandro de la Fuente Fernandez took it even further. Using PET scans, he showed that Parkinson's patients injected with saline, but told it was medication, released dopamine in their brains. Their movements improved, and the scans lit up with activity, all from expectation alone. Irving Kirsch's analysis of antidepressant trials revealed that placebos account for 40 to 60% of the symptom improvement seen in depression studies. These findings shattered the idea that placebo responses are imaginary. Each experiment leaves a clear trace in the body, endorphins, dopamine, or measurable changes in mood, proving that belief can be as real as any drug. A patient's belief in a treatment does not arise in a vacuum. The doctor's confidence, the tone of their voice, and even the ritual of the clinic visit all send powerful signals. When a physician speaks with assurance and warmth, patients are more likely to expect relief, and that expectation shapes what happens next inside the body. The simple act of receiving a pill from a trusted clinician can activate learned associations built over years. White coats, prescription pads, and the familiar taste of medicine all become cues that healing is on the way. This process is known as conditioning. Each time a treatment works, the brain learns to connect those sights, sounds, and routines with getting better. Over time, these cues alone can prompt the body to release endorphins, adjust immune activity, or dampen pain before any active drug is involved. The brain's prediction engine does not just wait for proof. It prepares the body based on what experience and social context suggest will happen. In this way, belief is built not only on hope, but on a foundation of trust, memory, and the subtle power of human connection. Placebos have clear boundaries. They do not mend broken bones, shrink tumors, cure infections, or reverse genetic diseases. Improvements are strongest for symptoms shaped by perception, pain, mood, fatigue, nausea, where the brain's expectations can directly influence experience. But when it comes to structural changes such as healing a fractured femur or eliminating cancer cells, belief alone is not enough. X-rays won't show a bone knitting faster because of a sugar pill, and scans won't reveal tumors vanishing through expectation. The placebo effect is powerful within the realm of subjective symptoms, but it cannot replace medicine where objective physical repair is needed. Ted Kapchuk's team at Harvard tested a new approach, telling patients outright that their pills were placebos. Even with full honesty, 59% of people improved after 3 weeks. That was far more than the 35% who received no treatment at all. Open-label placebos offer a way to harness the mind's healing power without deception, blending transparency with real, measurable benefit. In clinics and labs today, belief alone triggers real brain chemistry, sometimes rivaling active drugs. The mind's influence is measurable, not imagined. That frontier of healing still challenges everything we think we know.